Hello friends, welcome to the channel and thank you for watching this video. In this session, we are going to learn the next chapter from our Ansys SpaceClaim training module. The session is about solid geometry creation using pull option in Ansys SpaceClaim design modeler. So this video is the fourth chapter from Ansys SpaceClaim training module. Please refer the links below for other chapters from this training module. In this session, we're going to learn about all the pull options available in Ansys SpaceClaim Direct Modeler, which is also called SCDM. Pull option is used for creating and editing the 3D solid bodies. This is an important session since pull option is the only option that is mostly used for creating solid bodies from sketches and also editing those solid bodies. So let's get started. As we have learned about sketching in the last chapter, let's now look at the pull options available for creating and editing the geometry. The pull option is over here. As you know, once we exit the sketch mode, it takes us to the 3D mode and particularly to this pull option, since pull is the option that can create geometries using the sketch. For this session, let's now quickly create a sketch. So this forms our final sketch. Let's now go to the pull menu. We are now in the pull menu option. With this pull option, we can extrude a surface, revolve, sweep, offset, create drafts, and also scale the geometries. In this sketch, you can see that there are many surfaces here. As we learned that every closed loop of edges will form one surface each. That's why there are many number of faces. So we can use these individual surfaces for different pull options here. If you do not want any particular surface that has been generated here to be excluded from any further operation, then it can be deleted from here. For example, if you want to delete this surface, then you can just click on it and press delete key. So that surface will be deleted. Let's now look at some basic process that we need to follow while using the pull option. That process is going to be similar for other options in this pull tool. First, we need to select a geometric entity such as a point, line or a surface. Remember, you can pull point, line as well as a surface. Once you select, the selection information will be displayed right at the bottom of the screen. Also, once selected, you will notice the yellow arrow displayed here. Let's orient the model a little bit. You will also notice the two big arrows around the mouse cursor. These arrows prompt the user with the pull direction. This is usually set at a perpendicular to the geometry entity selected. In this case, you can see as we selected the surface, a perpendicular direction is chosen. This is just a default setting. We can always change this direction if needed. We will look at that at a later stage. We can now hold the left click on the surface or on the arrow and move this mouse cursor in the direction of arrow up or down. You will notice that the surface is thickening and a solid body is being created. You will also notice the dimensions here. You can release the left click and then type in the number for the height or the distance value here. Let's type in some number. I'm going to use 10 millimeter. Once you type in the number, then hit enter key. Once you hit enter key, the operation of pull will be completed here. You can then click on anywhere in the white screen to look at the result. There is one thing to remember here is that we do not necessarily need to click on an arrow or even a surface. We just need to hold the left click and move the cursor up or down in the direction of an arrow. Let's see this once again. Let me undo the steps up to the starting point of this operation. We have clicked on the surface already. So I am now going to hold the left click anywhere on the white screen and move the cursor up and down. Let's see what happens. You can see that the solid body is still being created. Let's switch to the full view. For this, you can either type a Z letter key or click the home button here. This will reorient your model in a kind of an isometric view. We can use the pull option for multiple surfaces at the same time. However, the pull distance will be same. Let's try to pull these two rounds at the same time. You can see that the 10 millimeter is same for both the solids. Let's try this with other surfaces. Let me choose this surface as well. You can see here that the solid body is created from those multiple surfaces. However, as those surfaces were connected, the solids got merged together. Now you can see one single solid. You can see this information over here. This is the solid which is just created, and this is the surface body which is yet to be pulled for creating any particular solid. Let's undo this to look at some other options. When you select this surface and you want to pull this surface exactly as the height of this solid, then we can use this option called up to. To use this option, you select the surface. We already have a pull direction here. We now can select this option which says up to, and then we need to provide a target surface or a target location. So this will be our target surface or up to surface. So once I select that surface, you can notice that the other surface got pulled exactly by the same distance of the earlier solid. You can click anywhere on the white screen to complete the operation. So this is how the up to option works. We'll see about that in more detail in the later part of this session. Let's try to pull the other surface with the same height. Let's select the surface and now select the up to option. When you select the up to option, you need to provide a target surface. So this will be our target surface. This will be just used to calculate the distance for pull. Once you select this surface, the pull operation will be completed. Pull is actually a very dynamic tool. In this case, you can see that we can dynamically change the height of this block by just moving the surface up or down. We do not need to do any extra step for this, like go to sketch mode or anything like this. As we looked at the structure tree, the solid is the one which we created and the surface are the rest of the surfaces which we haven't pulled those yet. In this case, you might have noticed that those surfaces we pulled will be gone or removed from the structure tree since those got converted to solid. If you want to retain those surfaces, you can always create a copy of those surfaces in case you need it. Let's now try to pull these corner surfaces. Let's try with the first surface. Let's see what happens if we pull these surfaces. You can see that the material is getting dynamically added and it is merging to the main block. You can also pull the two adjacent surfaces at the same time. During the pull operation, you can always specify a distance if you want those surfaces to be pulled for exactly same distance. As long as you have a surface, a planar surface, you can pull that in a perpendicular direction. So you can see as you move away from the solid, it is going to add the material, and as you move inside the solid or into the solid, it will remove the material. If you want to cancel any operation while you are into the pull operation, you can just hit escape key to come out of that option. If you want to modify any particular dimensions in this model, you do not need to go back to the sketch mode. We can do that in this 3D mode itself. That is why SpaceClaim is also called a direct modeler. For example, we can change the radius of these holes using the pull option. Select the round surface. You can see the pull direction is set perpendicular or normal to that surface. You can also notice the dimension here in terms of radius. When you select the surface, this will show its existing radius or a diameter in some cases. We can just type in a different number to update the hole here. Let me type a value of 5 and then hit enter key. You can see that the hole is now updated. Let me use some other number. Let's try changing some other dimensions. Let's try to change the radius of this hole same as the radius of this hole. For this, we can use a up to option here. Let's select this hole and then select the up to option. As we have learned, for up to option, we need to just provide a target dimension. In this case, that dimension will be the radius of this hole or cylindrical surface. So let's click on this and you can see the dimension or radius of this hole is updated to be the same as of this hole. You can click anywhere else and the operation will finish. Let's now try to move this angled face. This face adjacent to the angled surfaces. Select this surface, hold the left mouse key and move it in and out. You can see that the solid is getting updated. The side face angles are maintained here. The angles of the side faces are used as a reference or they are kind of a constraint. Inside the material we can only go till the surface becomes a line. In the other direction, we can pull the surface out of the solid as well. This will add the material. Now what if we want to move this surface straight into the material without changing its size, or without this quadrilateral reducing its size? You can do this by selecting this surface and the connecting edges at the same time. Once we select this surface and the two adjacent edges, we can pull this in the direction. You can now see that the angle constraint is bypassed and the size of the rectangle is same during the pull operation. We are not going to use these surfaces as we already had slots present here. So we don't need to use these surfaces. So you can go to the structure tree here, select the surface and hit delete key. This is going to be our final block and we are going to do some modifications to it. Let's now try to pull this angled faces and let's see what happens. Select the face and pull this in the direction in and out of the solid. You can see that the surfaces which are adjacent to this surface, the angles are maintained. Only this surface is shrinking or increasing in size. Now let's try to pull this surface, but let's not use the default direction which is perpendicular to this surface. What if we want to pull this surface in this horizontal direction? In this case, we would need to change the pull direction. For this, we can go to this option called pull direction. Till this moment, we use always the perpendicular direction. That's why we didn't have to use this option or select here. It will by default take the perpendicular direction. If you want to change the direction, then you can click here and then you can select any particular edge which will represent the direction. Let's select this horizontal edge. You can see that the yellow arrow is now oriented along this edge we have selected. Now this will be our pull direction. Please remember that by selecting this edge, we are just using it as a reference for the direction. This edge will not be pulled. Only the surface we selected will be pulled. Let's try this. You can see that the surface is now being pulled in the horizontal direction. So we have now learned how to change the pull direction as well. Sometimes the pull direction needs to be changed for the curved surfaces or such angled surfaces, or even pulling a flat surfaces in any tilted directions. Till now we modified the dimensions such as radius or the height. What if you want to add any feature on this model? You can do it right here in the 3D mode. Let's say if you want to create a small hole on this surface, a small through hole which passes through this surface. For this, we will need to create a small sketch on this surface. Let's select this surface and click sketch mode. Once you select that surface and click on sketch mode, you can see that the SpaceClaim has created a section plane of the model. So you can see that this is just an indirect way of creating a plane for sketching. We can now sketch anything on this section plane. Let's draw a small circle of some diameter at the center. Once done, we can exit the sketch mode using the green solid body symbol here or the pull button over here. Both will take you to the 3D mode. Let's use this option. You can see that the circle surface is created and imprinted on this rectangular surface. The rectangular surface is now split into two surfaces. One is the circle and the other is the rest of the rectangle outside of a circle. Let's create a hole now using the pull option. Click this surface. We're already in the pull mode. If you pull outwards the outside of the material or the block, the material will be added. But for the hole, let's pull this surface to the far right of this model. You can see the hole is now through. Once again, please note that if you pull outwards from the solid, it will add the material. And if you pull into the solid, it will cut or remove the material. We could also use an up to option for this. Let's undo this. So once we select the surface, click on the option up to and select the destination or the target surface. So this is our end surface. We can select this surface and you can see that the hole is now through. As we had learned, with the up to option, we do not need to enter the dimension or even move the cursor for doing the pull operation. We just need to select the target surface. Let's now look at some other options of creating a sketch plane. Let's say in this model, I want to make a horizontal slot here on both sides. For this, we will need a sketch. Let's select the axis of this hole and go to the sketch mode. You can see that as we had selected an axis, SpaceClaim has created a section plane along this axis. We can now create a sketch on this plane. I just need a slot starting from here. So let's orient the sketch first and create a rectangle for the slot. Once created, let's go to the 3D mode. You can see the surface we have created using the sketch. Let's use the pull option now. We can pull this surface in either direction. In this direction, you can see the material is getting added to the block. In the other direction, you can see that it is cutting the material. This is not what we want, so press the escape key to cancel the operation. We want a slot in both the directions. Let's try to see some other options to do this. When you select the surface, in the sub options, you can see this option called pull both sides. When you click this option, you can see the arrow is now changed to both the directions. So now when we'll pull this surface, it is going to be pulled in both directions. You can see that it is now adding material in both directions. But as you know, we want to cut the material to create the slot instead of adding the material. So let's undo this. In the same panel here, where we selected pull both directions or pull both sides, there is a sub option called cut. If you choose this option, then it means when we pull this surface, it will always cut the material, no matter whether it is pulled inside the material or outside the block. Let's try this option. You can see that the material is now being cut. And we have created a slot. Let's try some other type of pull options. In this case, you can see this is a round cylinder. We can make this oval using the pull option. For this, let's select the axis and select pull both sides. You can see the arrow change now to pull both sides. Simply pull this axis in this direction of the arrows. You can see that the cylindrical surface is now turning to the oval shape. You can always use dimensions for the exact shape. This option is just for pulling the circular faces. So in this case, the two semicircular faces of the hole was pulled apart. The next thing we are going to look at is the option for creating chamfers and rounds or fillets. For chamfers and rounds, we need to select the edges. Once we select the edges, we can pull in the direction of an arrow. And you can release the left click to end the operation. Once you release the left click, you will see the radius. You can always change the radius value and hit enter key. This will update the radius. You can then click anywhere on the white screen and this will end the pull operation. You can select this round option for multiple edges at the same time. For selecting multiple edges, you need to hold the control key and select the edges. Pull the edges in the direction of an arrow and you can see the radius or the fillet is being created. Once you release the key, you can just type in the value. You can use the up to operation here as well to create the same dimension fillets. For example, we can update this fillet using the up to option. Let's select this fillet surface, click this up to option and select the target surface. If this is our target surface or a target radius, then select this surface. Once you select this surface, you can see that the fillet radius is now 1 millimeter. Let's create some fillet or rounds on this edge. Select this edge and then pull into the solid. You can also create a full round. For example, let's create a full round for this flat surface. Let's undo. So we want to create a full round for this flat surface. For this, you can select these two edges of this surface and pull it into the material. You can stop it once the lines disappear. And click anywhere on the white screen, you can see that the full round is created. Let's undo this and let's look at some alternative option to do the same thing. Select the three adjacent faces and then right click on the faces selected and click an option called full round. You can see that it will also create the same result. Let's try this option with this face as well. Let's try to create some more fillet on the other side. If you want to create the fillets on all the top edges, then you can just double click on any edge and keep on double clicking until it selects a different edge loop. When you select the edges using this manner, you can still add any particular edge which is not selected, or you can remove any particular edge which is selected and you do not want it in selection. For this, you need to hold the Control key and select on the edge that you do not want in the selection. And now pull this arrow. You can see that all the edges are being pulled to create the rounds at the same time. Let's look at the rounds at the corners and some order of selections. It is always a good practice to add the vertical rounds first and then the horizontal rounds for the better and smooth results. Let's try to give the rounds to these edges. We can see that a sliver face is generated over here. So in order to avoid this, when you select this, there is this option called sweep around the corner. So you can see that it will create a nice smooth fillet around the corner. We have now looked at how to add the rounds to the surface edges. Let's now look at how to add chamfers to the model. When you click on an edge, you will have more options, whether in this mini toolbar or in this side panel over here. From here, you can see by default the option is set to round. We can switch to the option called chamfer here. Let's select this option and try to pull this edge in the direction of an arrow. You can see that a chamfer surface is now created. You can always use this dimension for the exact chamfer. You can also use an up to option for this chamfer as well. Let's select this edge and we're already in the chamfer option. Select the up to option and select this surface, this chamfer surface. You can see that the same chamfer is created onto the other side. Similar to the rounds, we can select all these edges at the same time by double clicking an edge and apply the chamfer. Right now it is in the round, so let's undo this and switch to the chamfer mode. You can see that this is the chamfer mode. And see, the chamfer is created for all those selected edges. So far, we have looked at just one method of pulling the surfaces to create solid bodies, like pulling the surface in one particular direction which was perpendicular or either horizontal or vertical. There are other ways of pulling the surfaces. Let's explore those one at a time. The revolve option is over here. If you want to pull the surfaces in a circular motion, then we can use this revolve option. Let's look at this option. For this, let's try to use a different window and create a simple sketch for revolve. So let's say we want to revolve this surface along an axis to create a 3D round solid. For this, we can select this surface and select an axis. So we need to select an axis about which the surface needs to be revolved or pulled in a circular direction. As you know, we have clicked on it, it has shown or provided a perpendicular or normal direction for the pull. But this is not what we want. Let's change the pull direction. Click on this revolve tool and select the axis. So this line will be our axis of revolution. Please note that even if this is mentioned as axis, this can be a line of the sketch or an edge of the geometry. So in this case, the axis is coinciding with the line or an edge of the surface. That's why we selected the edge. Once the line is selected, you will notice a rotation direction arrow is displayed. This prompts the user with the pull direction. You can also notice the two big yellow arrows by the cursor showing the pull direction. We can now hold the left click and move the mouse cursor in circular direction. You can see that the surface is getting pulled in a circular direction and a round solid body is being created. At any point, you can release the left click and type in the angle value. Let's say I want 180 degree. You can see that the 180-degree solid is created. Let me make a full round. Let's undo this step. You can always make it full round by pulling this surface in the direction of arrow and giving a value of 360 degree. It will make it a full round. For this, there is a shortcut option. Let's look at that too. So if you want to make a full round, then you can select this surface, select the axis, and then click on this full pull option. You can see that the full 360-degree round is created. Let's look at one point related to the revolve option. Let's undo this one more time. Once you selected the face and the axis of revolution, we notice the arrow here with the head pointing in one direction. So if you revolve in that direction of arrowhead, then the angles will start from 0 to 360 degree. You can see that the angles are from 0 to 360 degree as we are pulling the surface or revolving the surface. Let's now try to revolve in opposite direction. Let's undo this, and now we'll be revolving this surface in the opposite direction of the arrowhead. Now you can see that the result however is similar, but the angle values are starting from 360 degree towards 0. So if you need say 90 degrees of rotation, then you will have to enter the value of 270 here. So that will give you a 90-degree angle of revolution. Let's undo this and revolve it for the full round. Now let's try to create some other feature on this round solid body using the revolve option. Let's say if we want to create a circular slot on the outer surface of this cylindrical surface. For this, we'll need a sketch. Let's select the axis and go to the sketch mode. You can see the section plane is created. So I want to create a circular slot on the outer surface of this cylinder. So let's create a circle and snap it to the underlying edge of the existing solid. I'm using some random dimensions here. Once the sketch is created, we can come out of it and go to the pull menu. We can now revolve this surface about this axis to just cut the material. As we have learned, by default the option is set to the adding material or thicken surfaces. You can see this option is by default activated once you are in the pull mode. So once you select the surface, then we need to select the axis of revolution. In this case, the axis will be the axis of the cylinder. Once you hover your mouse over the axis, it will be highlighted and turn into a green color. Let's select this axis. Once the axis is selected, the direction of pull will be displayed. So this is going to be our direction of revolution. We can then click on this full pull for pulling this surface 360 degrees. But before that, as we want it to be a slot, then we need to cut the material. So for that, we need to select this option which will cut the material. Now we can select this full pull and the slot will be created. Let's move ahead for the next option. The option here is called sweep. With this option, we can pull the surfaces in any direction or a path. This does not need to be perfectly straight or perfectly circular. The path can be any random. Let's look at this option. We can even try this option for this slot. Let's undo. Let's select this surface and click on the cut option. Now instead of the revolve axis, we can provide the sweep path. So let's select this option. As the surface is going to be swept in a circular path, we can use the edge of the cylinder as our path. Once the edge is selected, we can use the full pull option for sweeping the surface. You can see that this has produced the same result as a revolve. But as I mentioned, for the sweep option, the path does not need to be a circular. It can be any random path. Let's look at this in more detail. Let's use a different design window. Now let's say we want to create a design of a 90-degree elbow. So for that, let's create a cross section of an elbow, the diameter. Let me select a diameter of 10 millimeter and let's come out of the sketch. So the circle will form the cross section or the diameter of the elbow. Now in order to create that 90-degree elbow, we will need a sweep path. So this will be swept along this random path. But in this case, we will have to create a sketch for the path. So let's create a plane. Select the plane option from here. And if you want a plane on YZ, then you can select the X-axis arrow. You can see that the plane will be displayed. Once you click on the X arrow, the plane will be created perpendicular to the cross section. Once the plane is created, we can come out of this option using escape key and select the plane and go to the sketch mode. You can see that the sketch mode is created exactly perpendicular to the cross section. Now let's create a sweep path here. Let's orient the plane. Now let me create the sweep path. I'm just drawing a path here for the sweep. So this is a path. So this does not need to be closed because this is not something we are going to pull. This will be used just as a reference for the sweep path. So as we have this path, which is just a bunch of lines connected together, we can exit the sketch mode. You can now see that we have a surface. In the structure tree also you can see a surface and three lines which are connected together, which will be our sweep line. Let's select this surface, and for the pull direction we are going to use a sweep option here. Let's select sweep option, and as you can see at the top, it prompts the information as pick a trajectory to sweep along. For the sweep, you can select these three lines or just double click on this first line and it will select the three connected edges or the three connected lines. Once the lines are selected, we can just click the full pull option here to create a 90-degree elbow. You can see that the surface is pulled along the path we had specified. So you might have now understood that we can use the pull operation or pull option for any surface along any path. Let's try to create a different path now. Let's undo this a few steps back till the sketch. So this is the sketch we had created. Let's use some different path. Let me select these lines and delete. And I'm going to use a polyline or a spline here for just randomly creating a path. So let's say this is the path I'm going to use for the sweep operation. Once the path line is created, exit the sketch mode and do the same operation. Let's select this surface, click on sweep and select the line. In this case, you don't need to double click because this was created in one shot using a spline option. So let's select this line and then click on full pull. You can see that it has created a pipe, a bent pipe using the sweep path we had provided. Let's now look at the next option. The other option is called a draft. Let's try to use a different window for this as well. Let me create some geometry to explain this option. Let's say this is a solid block and I want to use the draft on these surfaces, the vertical surfaces of this block. Let's try to put the draft on just one surface for the time being. So for this, let's select the surface on which the draft will be applied and then click on this draft option. Once you select this option, it will prompt the user to pick a plane to draft about. As we know that this face is going to be moved for creating the draft, so it is asking us to select the plane which will be fixed and will act as an anchor. For this, let's select this top surface as our anchor face. Once you select that surface, you can see that the value is shown here, which is nothing but the angle of the draft. And the draft, the direction is also displayed here. So let's type the angle, or you can move the surface along this arrow. You can see that the draft is created. And also you can enter the value for the draft. Let's undo this and try to create the draft on all the four surfaces. Let's select the all four vertical surfaces. You can use the control key, hold the control key for selecting the multiple surfaces. Now select the draft option and select the anchor plane. We can choose the angle by just entering the value, say just say 10 degree and hit enter key. You can see the draft is created on all the sides. So this is how the draft works. The next option is called scale option. Let's use the scale option on the same body here. This option just scales the geometry, like it increases or decreases the size of any geometry. Let's try this option. For this, we need to select the solid body. Let's triple click on any surface to select the solid body. You can see the information over here that one body is selected. And now we need to select the option called scale body. If you notice here, the prompt says pick an anchor point to scale the body from. This means that we need to select any point on this solid model for using the scale option. Please note that this point does not necessarily need to be on this solid. It can also be anywhere else in the space or on a different body altogether. Scale option will still work. For this body, let's select any point. Let's say this point. Once you hover your mouse over any corner, it will highlight the point. You can then select this point. You can see once you select the point, the arrows will be displayed. This is called an anchor point. This means that this point will be fixed during the scaling operation. Let's now pull along the arrow. You can see that it is scaling up in size, and we'll also notice the scale factor here, for example 1.17. If you want to double the size or you want to use an exact number for the scale, then you can just press the space bar. Please remember that you need to keep holding the left click when you will press the space bar. This will pause the operation for entering the value. So let's enter the value 2 and hit the enter key. You can see that the body is now scaled by a factor of 2. We have now covered all the options from here from the pull tool. There is one option we can look at from the side panel of the pull tool here, which is yet to be covered, and that is a very important option, and that option is called no merge. Let's use this existing block solid here to demonstrate this option. As a background, as you know that any assembly is a set of different parts or solids, such as there will be different parts in an assembly like gaskets, bolts, washers, etc., along with some other parts positioned together. The main point here to note that those parts will be different solids. Likewise, in simulations too, oftentimes we need separate solid bodies or fluid bodies for different parts for applying different types of meshing methods or different boundary conditions. During this pull operation, we always noticed that whatever we were creating on the solids or editing, it was merging automatically onto the main solid or main block. That is why we always saw one solid here. By default in SpaceClaim, if the surface or feature we pull is attached to the solid, then the newly created solid will get merged into that particular solid, or we can call it as a parent solid. We can, however, avoid that using this no merge option. Let's try this option. Let's say if we need a vertical cylinder on this block, kind of a bar for lifting this block. For this, we need to first create a sketch on this surface. Select this surface and go to the sketch mode. Let's draw a circle on the top surface and exit the sketch mode. Now if we pull this surface using the regular pull options, then it will still become a single solid. You can see that the bar is now merged into the block. But this is not the result we want. What if we want the cylinder or the bar as a separate solid and the block as a separate solid? Let's undo this. So as we have seen, by default, SpaceClaim tries to merge the newly created solid into the parent solid because the surface we pull belongs to the parent solid. In this case, this circle. The circle is part of this block, and that's why by default it merges into the block. So for this, if we want a bar as a separate solid, we need to separate this surface from the block. Right click on the circle and create a copy of it. Just click on copy and then right click again anywhere on this white screen and click on paste. You can see that we created a copy of this surface. If you hide this, you can still see this surface. So this surface is now part of this block. And this is the surface. This is just the surface now, which is a copy of the surface on the block. Now for this, let's select the surface which was copied and then use the pull option. As we have selected the surface here, the pull arrow is displayed. In this case, we need to select no merge option before we pull this surface. Now let's try to pull this surface. You can see that a separate solid is created for the bar. Now we can name it as a bar. So this is the way you can create different solids using the pull option. Let's try this one more time for a different geometry. Let's just create a pipe. This is for the internal diameter. Let's pull this for the length. So this is our internal solid, which is actually a fluid volume. Let's name it as a fluid volume. Now if you want the solid, then we need to create a sketch on this surface. Let's go to the sketch mode and create a thickness. So these are the two lines for the thickness, and let's exit the sketch mode. Now we have this surface for the thickness. Now here we can use up to option to pull this surface till the end of this pipe, which will be here. And along with that, we'll use a no merge option to create this thickness solid as a separate one. So let's select this surface and then click on the no merge option, and then lastly select this up to option and provide a target surface, which is for the distance. Once you click this, the solid is created. You can see that there are now two solids. This is internal solid and this is the thickness. You can also see it from here. Using the no merge option, you can create the different solids and avoid the solids which are created from merging into the parent bodies or the other bodies which are in contact. Hope you have learned all the options related to the pull tool for creating and modifying the solid geometries. This concludes the session. You can refer other chapters in this session. Thanks once again for watching this video. You can subscribe for more such videos.